Welcome back to another exciting chemistry lesson. In this lesson, we are going to look at physical change and chemical change, and then we are going to look at evidence of chemical changes. Well, first of all, what is a physical change? A physical change is not the same thing as chemical change. A physical change occurs when there is a change in intermolecular interaction. Well, that is between. So it's between the atoms and the molecules in that particular mixture. And the way it works is that the interaction between the molecules are broken and reformed. We are talking about the hydrogen bond. We are talking about the London dispersion. We are talking about the dipole and dipole interaction. And that is not the same thing as the actual bond that holding the atom together to form molecules. So again, physical change occurs when there is a change in intermolecular attraction or interaction. And we look at this carefully. The composition and the bonding arrangement of atoms in a compound, we talk about the chemical formula, okay? The chemical formula does not change. So we can abbreviate this. This could be chemical formula. So the chemical formula does not change, okay? And that is a physical change. So every time we think about physical change, the changes are changing in properties only. It doesn't change the composition or the bonding arrangement. Therefore, the chemical formula does not change. A common example of a physical change is a change in phases. And that is, we are talking about gases, liquid, okay, and another one is solid, and another one is aqueous solution. This one is when dissolved in water. So aqueous when we have something dissolved in water as an ions, okay? Now, when you dissolve table salt, for example, in water, it forms ions. For example, that ions, when you evaporate the water, it comes back as the solid salt. So that's a common example of physical change, okay? So basically, you have NaCl right here, dissolve into Na plus and Cl minus. And these are in aqueous form, AQ, okay? Aqueous form. And if you evaporate all the water, H2O, what you have left is NaCl, solid. So the composition does not change because, again, we're just dissolving it. In a chemical change, however, bonds are broken and formed. We are talking about ionic bond. We're talking about covalent bond, okay? And covalent bond are basically the single bond, double bond, and triple bond, okay? They are broken, and then before they are formed, the atoms are rearranged, okay? What does rearrange mean? Well, they switch places with other atoms and they form bond with different atoms. So that's the rearrangement part, okay? And they rearrange and they form new bonds. And a common example of a chemical change would be like this. O2 plus H2 form H2O. Okay, that's a common chemical change. You have one substance mixing with another substance. You have completely brand new product. Now we are going to look at common evidences that a chemical change has occurred. So basically, when there's a chemical change, there is a chemical reaction that has occurred, okay? Now, a common evidence is heat or light. Light, again, is basically a form of energy. So when there is a changes in energy, and again, heat, light, energy, represented by temperature. How do you know if heat energy actually occur or changes? And a common way is heat. You can actually feel it or you can see with light. But one way you can do is we can measure the temperature. If there's a temperature changes, right away you know there's a chemical reaction. Another common evidence is formation. That means you produce it. Okay. Or consumption, that means you use it, of gas. That is, the gas are being produced or being used. And how do you know? They are bubble forming. So we talk about bubbles, okay, circular bubbles in water. Those are formation of gas, okay. And how do you know the changes in gas is being consumed? we can actually look at the pressure. By looking at the changes in pressure or the changes in volume, we can determine that there are gas being produced or gas being consumed. When you consume, you use it up, okay? If you use it up, what do you get? This will have a decrease, okay, in pressure and volume, okay? And then another one we're going to see is color changes. If starting from clear to cloudy, this color changes. It changed color. And another one we have is formation of precipitate. Precipitate are basically solid, specifically insoluble solid. Insoluble means it doesn't dissolve. So I'm going to write this down. Does not dissolve. And this is usually in water, okay? In water. Now, another common evidence that we don't talk about is the change in mass. And basically, if there is a decrease in mass or an increase in mass, this is a good evidence that it is a chemical reaction has occurred. And basically, during chemical reaction, the bonds are broken between atoms, rearranged and form new substances. And that new substances can have more mass or less mass. So this is a very common evidence that we don't really see it until we actually measure it. And this is a very tricky one, okay? Now we are going to look at a particular diagram to illustrate a chemical reaction or chemical change. For example, in this case, illustrate the decomposition of hydrogen peroxide or hydrogen peroxide decomposed into water and oxygen. So I'm going to draw this out in terms of the product. So water, for example, water, we have what? We have oxygen. So I'm going to illustrate that as oxygen. And now I'm going to illustrate a solid one as hydrogen. So if that's the case, if this decomposed into water, we would have water look like this. So this is a common water molecules, okay? So it's going to decompose into a few water molecules. And of course, I'm going to draw a few of them only. And we talk about oxygen gas, so I'm going to draw double O. So this is a common example, okay? So I'm going to draw another water molecules there. And I'm going to draw another oxygen molecules with that. So that's a very basic particulate diagram of the decomposition of hydrogen peroxide. And over here, we talk about how hydrogen and oxygen combine to form water. So again, I'm going to label this as hydrogen, and I'm going to label this one as oxygen. So I'm going to have this at beginning. So we have a mixture of hydrogen and oxygen, okay? Hydrogen and oxygen. And this undergo through a chemical reaction, okay? And what do we have? Of course, we would have water. So again, water molecules. We have water molecules. And we have water molecules. Now, assume that a chemical reaction has gone through completion. That means you have used all of the reactant, all the hydrogen, and all the oxygen gas. So there is one type of gas that's remained, either oxygen or hydrogen, but you cannot have both, okay? Now, this is where it gets really tricky, and that is after completion. So what is really happening during after completion? That is, you have used all the limiting reactant. That is, of course, if you look at this right here, we have hydrogen and oxygen. Once you use all of them to make water, there's always one of them left over. And that is, again, the key is one of them has to be left over. It doesn't matter if it's oxygen or hydrogen. But after completion, there is a leftover of one particular gas. It doesn't matter if it's oxygen or hydrogen. The key is that it must be only one. Can only be one, okay? Now, let's go back to the same thing over here, okay? So we have nitrogen. I'm going to draw nitrogen. That is your nitrogen right there. And this is your hydrogen, okay? And, of course, if we mix them up together, we would have nitrogen gas, and hydrogen right there, okay? And we have another hydrogen right here. And if we mix them together and they form NH3, and what do we have? We have, there you go. And the same thing, okay, if this is happened to be after completion, that means you have used all the reaction, but again, one of the reaction will control how much of the product you make. So one of the leftover gas needs to be there. In this case, I can draw in hydrogen if I want to. The key thing is there is only one left. That's the key thing. There's only one left. You could have nitrogen gas or you can have hydrogen gas. It doesn't matter. It must be only one left because the other one have been consumed or used completely. So that is chemical changes and physical changes, as well as looking at common evidence of chemical changes and looking at a particular diagram of a chemical reaction after completion. And as always, if you have any question, please take a picture of your work and put in a form and we will help you from there. And we will see you next time on another exciting chemistry lesson.